Right. So hello everyone. So in this session, we'll be discussing about quantum mechanics. So before going into quantum mechanics, we need to look into the failures of classical mechanics and all those details. Instead of that, I'll start directly with the basics of quantum mechanics. Why is it introduced and what are its basic rules and regulations? Okay, so this quantum mechanics studies the properties of microscopic systems, where especially uncertainty principle plays a major role. సో ఈ అన్సర్టనిటీ అనేది డామినెంట్ ఎఫెక్ట్స్ చూపిస్తున్నటువంటి సిస్టమ్స్ స్టడీ చేయడానికి నేను యూజ్ చేస్తాను. సో అన్సర్టనిటీ అనేది ఎక్కడ స్టార్ట్ అవుతుందంటే, సో ఆరిజిన్ ఫర్ అన్సర్టనిటీ ఈజ్ వేవ్ పార్టికల్ డ్యూయాలిటీ. సో ఈ పార్టికల్స్కి కూడా వేవ్ నేచర్ ఉంటుంది అనేటువంటి ఒక అబ్జర్వేషన్ దట్ లెడ్ టు ద ఎంటైర్ బ్రాంచ్ ఆఫ్ ఫిజిక్స్, దిస్ క్వాంటమ్ మెకానిక్స్. ఓకే, సో ఈ వేవ్ పార్టికల్ డ్యూయాలిటీ ఎక్కడి నుంచి స్టార్ట్ అయింది? వేవ్స్ పార్టికల్స్, లేదు పార్టికల్స్ వేవ్స్ లాగా బిహేవ్ చేస్తాయి, లేదు వేవ్స్కి పార్టికల్ నేచర్ ఉంటుంది అనేటువంటి అబ్జర్వేషన్ అనేది ఇట్ వాజ్ ఫస్ట్ స్టార్టెడ్ విత్ లైట్. లైట్కి సంబంధించి వేవ్ నేచర్ ఉంది, పార్టికల్ నేచర్ ఉంది అనేటువంటి ఒక అబ్జర్వేషన్ ఉండింది డ్యూరింగ్ ద ఇయర్స్ 1910 నుంచి 1920 మధ్యలో. సో 1910లో మనకి బోర్స్ మోడల్ ఆఫ్ ఆటమ్ వచ్చింది అండ్ 1920 ఈ మధ్యలో క్వాంటమ్ మెకానిక్స్ మీద మేజర్ డెవలప్మెంట్స్, అటామిక్ ఫిజిక్స్ రిలేటెడ్గా మేజర్ డెవలప్మెంట్స్ అనేవి వచ్చినాయి. ఓకే, సో ఇక్కడ ఫస్ట్ అబ్జర్వేషన్ ఏంటి అంటే, దెర్ ఆర్ టూ ఈక్వేషన్స్ డెవలప్డ్ రిలేటెడ్ టు లైట్. వన్ ఈజ్ ఐన్స్టీన్స్ ఈక్వేషన్, E is mc square, another is Planck's equation, E is h mu. So these two equations describe the nature of light related to light. Here c is the velocity of light and mu is the frequency of light. So when you join these two equations, what do you get? This is you can write it as hc by lambda. So in total hc by lambda is equal to mc square. Otherwise lambda is h by mc. This is the equation developed for light. Then this de Broglie came into picture. D in German means D, a particular Broglie. We're talking about a particular person, Broglie. So he introduced a single statement that nature loves symmetry. So nature loves symmetry. And the further observation is nature is composed of either radiation or matter. So any entity in nature can be classified into either of these two. Either radiation ana avali ledu material particles ana ayi undali. And radiation is exhibiting dual nature, right? Radiation is exhibiting wave nature as well as particle nature. So ikkada manamu ee diffraction, interference, polarization ilantivanni ikkada explain chestunnam. And photoelectric effect, Compton effect లాంటివి particle nature తో explain చేస్తాం. So these topics also are there in your syllabus, so that we'll see in the later sessions. So ఈ photoelectric effect, Compton effect లాంటివి particle nature of light ని యూజ్ చేసి explain చేస్తున్నాం. So why can't we apply the same equation developed for light onto material particles అనేది in argument, because nature loves symmetry. So nature లో ఉన్నటువంటి అన్నీ కూడా సిమెట్రిక్గా ఉంటాయి. అంటే లైట్ అనేది కొన్ని ప్రాపర్టీస్ని ఎగ్జిబిట్ చేస్తుంది. సిమిలర్ ప్రాపర్టీస్ షుడ్ బి అప్లికబుల్ ఈవెన్ టు మెటీరియల్ పార్టికల్స్ ఆల్సో, అదర్ హాఫ్ ఆఫ్ ద నేచర్. సో అని హీ ఇంట్రడ్యూస్డ్ దిస్ సేమ్ ఈక్వేషన్ to material particles. So replace C with V. A simple modification to the existing equation. So this is the de Broglie's equation. So here we'll see the properties of matter waves. So material particles also behave or associated with wave nature. So V అనే velocity తో ట్రావెల్ చేసేటువంటి మెటీరియల్ పార్టికల్స్ అన్నిటికీ కూడా లాంబ్డా అనేటువంటి ఒక వేవ్ లెంత్ అసోసియేట్ అయి ఉంటుంది అనేది ఈక్వేషన్ చెప్తుంది. సో నౌ వాట్ ఆర్ ద ప్రాపర్టీస్ ఆఫ్ మ్యాటర్ వేవ్స్? Matter waves properties ఏమంటాయండి? So we are starting with this equation, lambda is h by mv. So when v is 0, lambda is infinity. So no wave. Wavelength infinity ఉంది అంటే ఏంటంటే length of single wave is stretched on to infinite distance. So when the particle is at rest, wavelength is infinity. No wave is associated with that. And with the rise in mass, wavelength reduces. With the rise in velocity, wavelength reduces. So if the particle is heavier, shorter and shorter waves will be generated. If the particle travels with larger velocity, shorter and shorter waves will be generated. In other words, if the P is high, lambda is low. So if the rise in momentum of the particle, wavelength associated with it reduces. So next one is velocity of matter waves. So I call it as U, to avoid confusion with V. So U is nu lambda. U is nu lambda. So for nu I can write it as E by h, and lambda is h by mv. This is mc square by mv. c square by v. So what do you get? U is equal to c square by v. So it is always greater than c. ఎందుకంటే since v is less than c. v అనేది c కన్నా తక్కువ ఉంది. ఒకవేళ ఇది ఈక్వల్ టు c అన్నట్లయితే విల్ బి లెఫ్ట్ విత్ c. Since it is less than c, this number will be greater than c. So matter waves travel faster than light. అయితే ఇక్కడ ఒక చిన్న మ్యాజిక్ జరిగింది. యూ నీడ్ టు ఐడెంటిఫై. ఏంటంటే యాక్చువల్ ఈక్వేషన్ ఈజ్ లాంబ్డా ఇస్ h by mc and we just by hand modified or replaced c with v. ఇక్కడ ఏం చేస్తున్నాము, e is equal to mc square అని రాసేస్తాం. యాక్చువల్గా mv square అని రాయాలి కదా, అదర్వైజ్ ఇక్కడ కూడా mc అని రాయాలి. సో వీఆర్ సింప్లీ మ్యానిపులేటింగ్ థింగ్స్ యాక్చువల్లీ. And in fact, it is a fact actually, matter waves travel faster than light. But actual situation enti, no entity in this world travels faster than light. Adi matter wave aina sare, ఏ wave aina sare, anything ఏదైనా సరే లైట్ కన్నా ఫాస్ట్గా ట్రావెల్ చేసేది ఇది. దెన్ వై దిస్ డిస్క్రిపెన్సీ? అదే మనం ఈ రీప్లేస్ చేయడంలో ఏదో చిన్న ఇష్యూ చేసాం. ఓకే, but still this statement is valid. Matter waves travel faster than light. Reason enti ante we need to come across two things, group velocity and phase velocity ani rendu vastayi. Okay, group velocity and phase velocity. Group velocity ante enti ante it is the velocity of group of waves. So when you combine a group of waves with different wavelengths, you will be left with a wave packet. Group of waves with different wavelengths or frequencies mix అయినప్పుడు ఒక wave packet అనేది వస్తుంది. The velocity of wave packet is the group velocity. Okay, and velocity of individual waves is the phase velocity. Group velocity deals with velocity of group of waves or the wave packet, whereas phase velocity deals with velocity of individuals. So here comes another concept of dispersion equation. So it is the equation that connects energy with momentum of the particle. Dispersion equation deals with a relation between energy and momentum. So material particles ki light ki సంబంధించి energy momentum equations ఎట్లా ఉన్నాయనేది చూడాలి. ఓకే, సో లైట్ కి సంబంధించినటువంటి ఈక్వేషన్ ఎనర్జీ అండ్ మొమెంటమ్ కి రిలేటెడ్ కనెక్ట్ చేసేటువంటి ఈక్వేషన్ ఏముందంటే మనకి ఈజ్ p square c square plus naught square c power 4 e square x. Relativistic energy relation. అయితే ఇందులో ఫర్ లైట్ rest mass of photon is 0. When you stop the photon, it simply disappears. So photon existence occurs only when it is moving. Move అవుతున్నప్పుడు మాత్రమే photon కి existence ఉంటుంది. Rest mass of photon is 0. So when photon comes to rest, it simply disappears. అదొకటి తెలుసుకోవాల్సిన విషయం. So then this equation turns into E equal to Pc for photon. సో ఈ ఈక్వేషన్ మనం కొన్ని చిన్న చిన్న మార్పులు చేద్దాము. So here it is, I write it as h nu is equal to h by lambda. So it is nu is c by lambda. And here I am introducing a factor of 2 pi by hand. So importance of 2 pi I will discuss in the later sessions. But whenever we have a periodicity or repeatedness, because we are dealing with waves somewhere, the entire story, the hidden agenda is waves. So wherever you have a repeatedness, that periodicity, you will be comparing things with the periodicity of circle, the best known periodic system. So the motion in circle, the best known periodic system. It repeats forever. Right? So there a factor of 2 pi comes into picture when you deal with equations of circle. Okay, that we'll see. So here I am introducing a factor of 2 pi by hand. So 2 pi nu is equal to 2 pi by lambda into c. And I am calling it as a new parameter. So this is omega is equal to kc. So instead of nu, I will be using omega. Instead of lambda, I will be using k in this entire quantum mechanics. So this is the dispersion relation related to light. Okay, so now I am going to define group velocity and phase velocity. Okay, so this phase velocity is omega by k. And group velocity is d omega by dk, that is also c. So for light, both are same. Okay, now I go for material particles. So we have to see a relation between energy and momentum for material particles. Okay, so the equation is E is p square by 2m for material particles. So now I have to introduce this. So h nu is equal to h square by lambda square by 2. So these definitions, I am going to use these definitions again. 2 pi nu is omega, 2 pi by lambda is k. Okay, and I am also going to use another definition, h bar, which is h by 2 pi. So I write it as h by 2 pi nu is equal to h square by 4 pi square lambda square by 4 pi square. This is h bar omega is equal to h bar square k square by 2. So in total, omega is equal to h bar k square by 2. So now we use these equations for phase velocity and group velocity. So Vp is omega by k, which is h bar k by 2m. Vg is d omega by dk, 2 h bar k by 2m. H bar k by m. Conclusion is Vp is equal to Vg by 2. Clear Ganara? Why do? So h bar k by m is Vg, group velocity. So here comes the most important observation. So if you draw this dispersion curve, means a graph between energy and momentum, or a graph between omega and k. So energy versus momentum, or omega versus k. For light, you will get a straight line. This is for light. And for matter waves, you get a line, a parabola. Omega is h bar k square by 2m. So omega is proportional to k square. So you get a parabola here for matter waves. But for light, you get a straight line. So now comes the discussion of what is the slope of this curve. What is slope? It is either omega by k or d omega by dk. What do you get by calculating this omega by k? What do you get actually? What is omega? 2 pi nu by k is 2 pi by lambda. What is that? That is nu lambda velocity, right? So if we calculate the slope of the curve, you will get velocity. That is what we are using here actually. Okay. So now if you see the slope of dispersion curve for light is constant everywhere. So it is a straight line. So if you take this ratio of omega by k, let's say this is 2 and 2, maybe 3 and 3, 4 and 4, everywhere the slope remains same. Okay. So that means for all colors, velocity is same. Whatever may be the wavelength or whatever may be the frequency of light, the velocity is same. Okay. So I have to write the observations. Some space here. So for light, so with the rise in omega, k rises and omega by k is constant. So in terms of frequency and lambda, what do you conclude? If omega rises, frequency rises, and with the rise in k, wavelength reduces. So nu increases and lambda decreases, and the product of nu and lambda is constant. Rise in frequency, wavelength reduces. That is for light. Whereas for material particles, the story is different. Here the slope is lower, and if you go on rising the value of k, slope is increasing. Omega value is rising faster compared to k. So what is that? d omega by dk or omega by k increases. It is rising at rate. Omega value increases fast compared to k. So what is the conclusion? What is the relation between velocity and wavelength for material particles? So lower the value of k, higher is the wavelength. So when k is smaller, lambda is higher. For lower values of k, what is the velocity? Slope is lower. So with the rise in k, wavelength reduces and velocity increases. So faster the material particle, shorter is the wavelength. Here also, but for light, all wavelengths will have same velocity. So that is the one drastic difference between matter waves and light waves. సో ఇక్కడ ఈ రెండు ఈక్వేషన్స్ నుంచి మనకు వచ్చేటువంటి ఒక కన్క్లూజన్ ఏంటి అంటే గ్రూప్ వెలాసిటీ ఈజ్ లార్జర్ కంపేర్డ్ టు ఫేజ్ వెలాసిటీ ఫర్ మెటీరియల్ పార్టికల్స్. Okay, so the relation between these two is if you go with some mathematical calculations, Vg is equal to Vp plus dVp by dt. Because this phase velocity changes with wavelength for material particles. Okay, so the relation between Vg and Vp is Vg is equal to, Vg is larger, Vg is equal to Vp plus dVp by dt. But for light, phase velocity is same for all wavelengths. So dVp by dt becomes 0 for light. So Vg is equal to Vp for light. Okay, so always group velocity is larger compared to phase velocity. So if phase velocity is constant, both will be equal. Group velocity is equal to phase velocity when phase velocity remains constant forever. So if phase velocity changes with wavelength, group velocity dominates. So these variations in group velocity, phase velocity, this manipulation creates this discrepancy. Matter waves travels faster than light kind of conclusion comes because of that. Phase velocity and group velocity variations will make that. So sometimes the phase means what? That extra factor that comes in a wave. Means some shift. Right? Let's say we have sin omega t, some graph, plus some 30 or 20, some extra phase is there. What happens? The curve shifts, either forward or backward. Right? So that phase shift gives an impression that the wave is traveling faster than light. Okay, normal wave is traveling with some velocity and with some starting point. Because of this phase shift, the wave may shift forward or it may shift backward. So if it shifts forward, at the end what we see? The shifted wave is traveling faster kind of effect will be observed. But actual velocity is same, but because of the shift, it may appear in a forward position. Okay, so that is the only difference, that matter waves may appear faster than light because of the phase shift. Ultimately, they cannot travel faster than light. That is a primary conclusion. But this discrepancy is because of the phase shifts. Okay, this is the rest of the topics we will discuss in the next session.